I mentioned that, as it turns out, log and exponential functions are closely tied to each other, and they are, in fact, inverses of one another. In the same way that x squared and square root x are inverses of each other, or are functions that can undo one another. If we square a number and then take its square root, we get back to that original value that we started with. So those are kind of opposite operations, or the more appropriate word there would be inverse operations of one another. Unfortunately, seeing the connection between the two can be a little confusing at first. We just sort of need to get used to this idea. If we have the log base b of a is equal to c, that's the same thing as saying b to the c power is equal to a. If you're encountering this for the first time, that's not, again, a super intuitive relationship between these two expressions. But what we're doing is taking whatever the base of that logarithm is, and we're raising it to the power on the opposite side. And then the value that we were taking the logarithm of just becomes the freestanding value on the other side of the equation. And we need to get comfortable with moving back and forth between these two different types of notations. To do that, we'll look at a few examples where we rewrite some logarithms as exponential functions and vice versa. In example 1, we have the log of 5 is equal to n. Keep in mind, since we don't have that base written there, this is assumed to be log base 10. And what we'll do is take that base, raise to the value on the other side, set equal to the number that we were originally taking the log of. So this is going to become 10 to the nth power is equal to 5. These two expressions are equivalent to one another. For the log base s of 14 to the x power, again, we just take that base, raise it to the power on the other side to get s to the x power is equal to 14. In example 3, we have a natural log, ln. So this is the same thing as log base e of t is equal to 3. We'll take that base, raise it to the power on the other side. So we'll get e to the third power is equal to t. Now what we want to do is work that problem in reverse. Starting with an exponential expression, we want to convert that to a logarithmic expression. Whatever value we have being raised to a power, that's the base of the exponential expression. So that's going to be the base of our logarithm. Whatever value is on the opposite side of that equation becomes the expression that we're taking the log of. And then the exponent stands on its own. So this will become the log base 10 of y is equal to 5, which we could just shorten to log of y equals 5. Similarly, we have a base y exponential expression. So this will become the log base y of whatever that value is on the opposite side, set equal to whatever expression is in the exponent. So we'll get log base y of 13 is equal to t. And then for the last one, we'll get log base e of 7 is equal to 5, or is equal to s. And since we have log base e, we could rewrite that as natural log ln of 7 is equal to s. Again, this relationship doesn't seem incredibly intuitive. For the most part, logs and exponentials are functions that we have less experience with versus just exponents and radicals, so power functions and roots. But we just need to get in mind how those two statements relate to each other and how to make those conversions.